All right. Hi again, everyone. Welcome to week 3 of our online learning here. To start this week off, I thought we'd keep it light without having an actual written assignment for you, but instead going over what maybe what good approaches were to the problems from that Edulastic assignment from last week were. One of the things that I got as feedback from that Google form that you completed was that some of you would like a little more explanation, a little more help with how to do some of the problems. So I wanted to take time to really break down this assessment. There was a lot of good stuff on there. Some of the things were worded slightly different than we're used to seeing, but they were all using the same concepts that we've been used to. So we'll look at each question one by one, and I'll jump over and show you how we could go about solving that one. And then after you've watched this, if you still find that you have any questions, you can send me a message on Google Classroom, and we'll see if we can't get to the bottom of things. So let's get going right away here. First up, problem 1, you're asked to find the solutions to this quadratic equation using the quadratic formula. And then they give us multiple choice answers, but really we shouldn't even worry about those right now. Let's just see what we come up with if we use that formula. So the equation is x squared minus 5x minus 14 is equal to 0. And right away we want to be thinking, okay, what are our a, b, and c values that we're going to plug into the quadratic formula? So a always comes in front of the x squared term. There's that hidden positive 1 there, so that'll be a. B is in front of the x term. It's 5, but it's also subtraction, which is the same as adding negative 5. So b is actually negative 5. And then c, same idea. It's subtracting 14, so it's actually negative 14. Remember, the quadratic formula works to solve the x-intercepts or values of x when the equation is equal to 0, because when y is 0, that puts us on the x-axis. So now that we have a, b, and c, we can plug those into our quadratic formula. Just a reminder what that is. So when we're solving, it says that x will be equal to the opposite of b plus or minus the square root of b squared minus 4 times a times c. And then all of that is over 2a. Since we've already identified a, b, and c, we need to carefully plug those values in and then make sure we carefully follow the order of operations. So as we do that, we'll see that x is equal to negative 5. It'd be fine to just jump right ahead and put positive 5 there, but we'll start with that. And then we're taking the square root of b squared, so negative 5 squared minus 4 times a, which is 1, times c, which is negative 14. And then that's all over 2 times 1. So right away, my suggestion would be try to do all the simple math you can to make this look a little bit easier. So we'll see that x is equal to positive 5 plus or minus the square root. Well, negative 5 squared is positive 25 minus 4 times 1 times negative 14. Well, 4 times 1 is 4 times negative 14 is going to give us 28 into 56. So 25 minus 56 in our square root. That's all over 2 times 1, which is just 2. All right, so we've got things looking pretty simple, but I identify a problem right away because I see 25 minus 56, which lets me know I think I made a mistake because that'll give me a negative that I can't take the square root of. So if I look back, subtraction is here, and there's also a negative 14. So I'm actually subtracting the negative 56 I get from multiplying 4 times negative 14. So minus negative 56, which is the same as adding. And that's an important thing to catch. That's a common mistake that we can make there. So with that correction, let's simplify things even further. So x will be equal to 5 plus or minus the square root. If we add 25 plus 56, that gives us 81, which is good news there since we're taking the square root. And then that's all over 2 still. Let's jump down to another page. So we had x was equal to 5 plus or minus the square root of 81 all over 2. We know the square root of 81, so we can say x is equal to 5 plus or minus 9 all over 2. At this point, we need to split up into two equations, so we'll see that x is equal to 5 plus 9 over 2, and then separately, x is equal to 5 minus 9 over 2. If we solve those out, we get 14 over 2, or 7. And then here we get negative 4 over 2, or negative 2. So that tells us our answers for x, or our solutions, are 7 and negative 2. If you go back and look at that assessment, that was that first choice, x was equal to 7 and negative 2. So that's just a matter of using the quadratic formula. You'll notice we didn't even need a calculator as we went through that problem. That's not always the case. We got lucky that the square root of 81 showed up in that problem because it made it simple to work with, so we didn't need to do any kind of calculator work. All right, our next problem told us to select the solutions to this quadratic equation. Again, those solutions are like the x-intercepts, because that 0, which I wish I could circle but I can't, that's where y would be, so that's indicating we're on the x-axis, we're finding x-intercepts. Well, to get our solutions, let's take that quadratic x squared minus 6x plus 8 and see what we can do with it. So if we work with x squared minus 6x plus 8 is equal to 0, our first step should be factoring to see if we can get actual factors and solve from there. So I put x squared in one corner of my rectangle and 8 in another. When I multiply those across, I get 8x squared. That's the top of my diamond. And then negative 6x goes in the bottom. So factors that multiply to 8x squared and add to negative 6x would be negative 4x and negative 2x. So we're lucky that works out. We fill in the rest of our rectangle, and now we take some greatest common factors. So I know we're doing x times x to get x squared, and then between 8 and negative 2, I'll take out negative 2. Between negative 4 and 8, I'll take out negative 4. So our factors are x minus 4 multiplied by x minus 2, and those will be equal to 0 because they're replacing the left side of the equation. Those are equivalent. Now we use that zero product property, which says when two things multiply together to give you 0, one of them has to be 0. So x minus 4 could equal 0, or x minus 2 could equal 0, and that means x is equal to positive 4 and x is equal to positive 2. So those are our solutions. If we go back and check, sure enough, I see x equals 2 and x equals positive 4 as our first two choices, so we should select both of those. All right, next up, factor the following expression. That's going to look pretty familiar to what we just did. So it's x squared minus 15x plus 56. X squared minus 15x plus 56. They didn't tell us to solve. We're just breaking it down into factors, and we'll use that rectangle and diamond structure to do that. So if we put x squared and 56 in our corners, that gives us 56x squared, and then negative 15x goes in the bottom. So to multiply to positive 56 and add to negative 15, I think we're going to be working with negative 8 and negative 7, and then we'll need our x's to make that work out. So we've got what to plug in here, and then we just take out our greatest common factors again. So that means we'll take out negative 8 and we'll take out negative 7. Our factors are x minus 8 multiplied by x minus 7. And that's all we had to do for that problem. We didn't have to go further to solve. We were asked to factor another one. This one, believe it or not, you didn't actually need the generic rectangle if you recognize that you had the difference of two squares there. Anytime we see that, in this one we had 16x squared minus 25, I know right away that we'll take the square root of each term and put that in. So I'll have 4x in both parentheses, and I'll have 5 in both parentheses. One will be added, one will be subtracted, and those are our factors right away. You could check that by multiplying them in a generic rectangle. If you don't recognize the shortcut, you can use the generic rectangle and diamond to factor, but the shortcut's nice because we could get that answer right away. All right, moving along, multiplying binomials. This is another task for the generic rectangle, so we'll put x minus 7 and x plus 3 on the outside of a rectangle. So x minus 7 and x plus 3. And not that it matters, but actually I'll flip that so that it appears the same way we've been factoring. So x times x will give us x squared. 3 times x will be 3x. Negative 7 times x is negative 7x. And 3 times negative 7 is negative 21. So that tells us we have x squared minus 7x plus 3x minus 21. And if we combine like terms, that gives us x squared minus 4x minus 21. So that would be what it looks like when we multiply that binomial. All right. Now, on to the next problem. This one asked us to graph a function, and we were given 4 choices. Although I'm having a little trouble scrolling through on my iPad. But that's okay. We don't need those anyway, because right away when I'm thinking about graphing, I want to be thinking about, okay, what's the y-intercept, what are the x-intercepts, and what is the vertex? So getting those key points will make it really easy to determine what the graph should look like. So we have 4x squared minus 8x plus 7. 4x squared minus 8x plus 7. And that was f of x. They could have used y as well, but it's written with function notation here. It doesn't change our process. So to get the y-intercept, remember that's the value when x is 0, so that we're on that axis. By putting in 0 for x squared and 0 for x, those cancel out completely, and we're left with 7 as our y-intercept. So the y-intercept is 7. Believe it or not, that was actually the only thing you needed to be able to identify which graph matched this, because only one of them had a y-intercept of 7. You could keep going, though, and to continue, you would be thinking, okay, how can I get my x-intercepts, or values when y is 0? So you'd be solving 0 is equal to 4x squared minus 8x plus 7. That's when we can try to factor first, and if that doesn't work, then we have to move on to another method. If we look at factoring, so we'll put 4x squared in a corner and positive 7 in a corner. So we're working with 28x squared and negative 8x. So we have to think, okay, factors of 28 that add to negative 8. Well, 28's factors, 28 and 1 won't do anything. 14 and 2, there's no way we'll get to negative 8. If we look at 7 and 4, again, I don't think we're going to get to negative 8 that way, which makes me think we might not be able to factor this one. That moves us on to something like the quadratic formula, which you can go back to the first problem to look at how to do, and completing the square, which we'll be doing in just a moment here. So those are other methods you could use, but ultimately you didn't need them because that y-intercept was all you needed. All right. Back to factoring, x squared plus 9x plus 14. I believe we should be getting pretty good at that by now. That'll involve that same generic rectangle and diamond problem structure. So I'll leave that one for you guys to work now that you've seen the other ones. But looks like we should have x plus 7 and x plus 2 as our factors there. So try to factor it and see if that's what you get, x plus 7 multiplied by x plus 2. All right, so this one was an interesting one. We were asked to complete this quadratic to make it a perfect square. And that's meaning complete the square, but they gave us an easy one because we get to fill in that third term to be exactly what it needs to be. So x squared plus 18x plus something would be a perfect square. And what that means is that we'll use the process of completing the square to have something just in parentheses. So x, and then we got the x from taking x squared and taking its square root. Remember, to get the other term, we cut 18 in half, and we get 9 in there. Since it was addition, we're adding. So that's our perfect square, x plus 9 squared. If I multiply that in the rectangle, you'll see right away you get the x squared you had originally. When you do 9 times x, you get 9x here, and 9 times x, you get 9x here, which is the 18x you had. The change is 9 times 9 is 81. We didn't have 81, but that lets me know that's the number we should add to make it a perfect square. So that was the answer to that one, was 81. All right, moving right along. So this one was another one to think about completing the square. It was given in a tricky way because it wasn't set equal to 0 or y. It was set equal to 22, and then the answers all were equal to a different number. I think our best approach is to rearrange this equal to 0 at first, and then see what happens when we complete the square. So x squared minus 12x plus 49 is equal to 22. X squared minus 12x plus 49 is equal to 22. Let's, as a first step, move that 22 over. So we have x squared minus 12x, and then 49 minus 22 gives us positive 27, and that's equal to 0. Now to complete the square, we'll do like we did in the previous problem. We'll fill in, using the first two terms, x, and then half of 12 is 6, because it's subtraction. We'll subtract here. This time, if we were to multiply that out, so x minus 6 and x minus 6, we get the x squared we had. We're going to get the negative 12x that we had, but we get positive 36. That means that's in there right now. The issue is we only had 27 to start with. So we have to go from the positive 36 we have in this new square we created back to 27, which means to get from 36 to 27, we subtract 9, and that's equal to 0. So x minus 6 all squared minus 9 equals 0. That's our perfect square, or our graphing form of that equation. If I look at the answer key, that's not exactly there, but there is x minus 6 squared is equal to 9. Going back to that problem, if I can find it. There it is. If I add 9 to each side, my equation is still balanced, and now it looks exactly like what they show in the answer key. The reason that that's nice is because if I want to find the x-intercepts, I can continue from there by taking the square root of each side and solving for those two x-intercepts. All right, moving on to the next question. So this one, they want to know which one has been clearly showing the vertex. Well, when I hear that, I think the easiest way to identify a vertex is to have something in graphing form, which means problems C and D. So your job is to take that original equation, x squared plus 2x minus 3, and write that in graphing form. The correct graphing form is x plus 1 squared minus 4. And so then our job is to just recall, how do we identify the vertex? To do that, we would take the opposite of the value in parentheses, meaning since it's positive 1, the vertex would be negative 1, and then the value outside parentheses, we keep the sign. So it would be negative 4. So the coordinates of your vertex are negative 1 comma negative 4, which made D the correct answer. All right, here was a good real-world scenario that involves a quadratic. We're working on a rectangular soccer field that has an area of 4,000 square units. It must have 30 yards for its length, or excuse me, the soccer field must be 30 yards longer than its width. So that's enough information right there to write an equation and figure out what our width could be if we wanted to. We know 4,000 is the total area, and that'll be equal to the length times the width. The issue is all these equations just contain the width, so we need to find a different way to represent the length. They say the length is 30 yards longer than the width. So the length would be W plus 30, and you'll see in B, 30 plus W shows up, so there's your length multiplied by just the regular width, and that should give you the full area of the rectangle, which is 4,000 square feet. So B is your correct answer. All right, we're asked to solve an equation by completing the square. Let's actually do this one together. So x squared plus 10x minus 51 is equal to 6. X squared minus 10x plus 51 is equal to 6. So that's our equation. Just like before, let's get it equal to 0 first by subtracting 6. So x squared minus 10x, and then 51 minus 6 is 45. And that'll be equal to 0. So there's our equation. Let me just double check and make sure I wrote everything correctly. X squared plus 10x minus 51 is equal to 6. And this is why you always double check. If I go back and look at what I wrote somewhere. Uh-oh. I'm not sure where it went, guys. Well, that's okay. I didn't. Oh, there it is. So I wrote plus 51, but it's actually minus. Let's get to a new page anyway. So x squared. Now I already forgot if it was positive or negative 10x. Plus 10x minus 51 is equal to 6. X squared. X squared plus 10x minus 51 is equal to 6. All right, so by checking our work there, I was able to catch that small mistake. Now when we subtract 6, we will get x squared plus 10x minus 57 is equal to 0. Now we were asked to solve using completing the square, so that means I'm going to have something in parentheses squared plus or minus something on the outside. So in the parentheses, I look at the first two terms. X goes in there because it's the square root of x squared. And then 10x, we cut that 10 in half to get 5. Since it's positive, it's plus 5. To use a shortcut, I know that x squared and 10x will show up if I'm multiplying the rectangle. But when I do 5 times 5, I get 25, not negative 57. So I need to find, how do I go from the positive 25 I just created in this parentheses back to the negative 57 I started? Well, I know I'll be subtracting, and so you can do two things. You can think, okay, 25 minus what is equal to negative 57? Or you can just do negative 57 minus 25. So you could think of it that way as well. And to do that, I find the absolute difference there. 57 plus 25 is 82, and it'll be negative. So I have to take away 82 from 25 to get to negative 57. That's still equal to 0. All right, to solve, we're going to use inverse operations now. So we'll add 82 to each side. And that means that x plus 5 squared is equal to 82. Ooh, that's unfortunate because the next step is to undo squaring by taking the square root. And 82 is not a perfect square. 81 would have been nice, but that's okay. We can still work with it. So on the left side, square rooting cancels out squaring, and we're left with just x plus 5. If I want an exact square root of 82, I'm going to sneak over to Desmos real quick. So the square root of 82 is actually 9.055385138. Ooh, and I called that exact earlier, but really what we're getting is an approximate answer because we're going to round this to 9.06. So our rounded square root is 9.06. I wrote it as positive, but because we're taking that square root x plus 5 could technically also be equal to negative 9.06. Those are my two equations to solve, so I'll subtract 5, and I'll see that x is equal to 4.06. And when I subtract 5 from the other equation, I'll see that x is equal to negative 14.06. So those are the two solutions, the two x-intercepts for that equation. And going down the list, they actually left it as negative 14.055. So they didn't, and then 4.055, they didn't round to the hundredths place like I did. They rounded to the thousandths place, but either way, we're rounding correctly. All right. A quadratic equation is shown here. Which value is a solution to the equation? Well, we could factor and get those answers, or we could just try plugging in numbers. Me personally, if I've been practicing my factoring, I can do it quickly, and I'll see that we could do x minus 4 times x plus 1 as factors. And then the zero product property would mean that x would be equal to positive 4 or negative 1. So D of 4 would be a correct answer. And I'll let you guys go back and try to factor that and solve. All right, this next one, choose all the functions below that have a vertex of 4.5 and negative 8. We're going to use that rule we talked about earlier, where inside the parentheses squared, we'll always flip the sign to get the x-coordinate of our vertex. And then outside the parentheses, we keep the sign the way it is for the y-coordinate. So we know we need positive 4.5. Anytime I see minus 4.5 in parentheses, that could work. We know we need negative 8, so I have to see negative 8 outside parentheses. It does not matter if you have a positive or negative value, like 2 or negative 1/2 in front of the parentheses. You will still have the same vertex for all of those parabolas. What changes are the x-intercepts and the direction it opens, but ones like part A, part B, part C, not part D, but part E, and then not part F, those all work because they have those requirements we need. All right, on to our last question, factoring completely, and this is something we talked about before we got this break from each other. So let's do that one together. 4x squared minus 4x minus 24. So I said 4x squared minus 4x minus 24. Now I just want to make sure that was all subtraction. All right, so double checking that. Now going back to factor. To factor completely means we want to take out that 4 from everything. So if I divide everything by 4, it becomes 4 multiplied by x squared minus x minus 6. Now I just factor what's in those parentheses using my rectangle and diamond. So I'll be looking for something that multiplies to negative 6x squared and adds to negative x. That looks like it'll be negative 3x and positive 2x. So I fill those in and then take out my greatest common factors. I'll see that I have x minus 3 multiplied by x plus 2. The 4 needs to come back. It's still multiplied by those. And my full factorization is 4 times x minus 3 times x plus 2. All right, guys, and just like that, we've completed the entire assessment, and hopefully having me talk through it has cleared up any confusion you had about any of these problems. I know I went kind of fast, but remember, you can always pause, rewind, go back and look at any concepts that you have. You don't have any additional homework today, so please take your time and make sure you understand the concepts that were in here. Overall, we were a little bit over 80% as a class on this, which is okay, but hopefully we're striving to get a little bit better so we can be really comfortable working with some of these different strategies to solve quadratics. All right, guys, thank you for tuning in, and have a great rest of your day. Check Classroom tomorrow for our next assignment.